Welcome everyone to an existing upcoming series where I will explain in detail all the stages of gold processing using the heap leaching method, include agglomeration process, heap leaching process, absorption process, stripping process, melting process, laboratory stage, all documents work. This series will be valuable for mining engineers, chemical engineers, geologists, processing and lab technicians, and everyone interested in investing in the mining and gold production industry. In this video, we will begin with the first stage, which is agglomeration process in gold extraction via heap leaching. So without further ado, let's get started. Agglomeration process is a crucial step in improving the efficiency of gold extraction using the heap leaching technique, especially when processing low-grade ores or clay-rich ores. Rotary Drum. The importance of agglomeration lies in enhancing permeability and preventing clogging of the heaps due to fine clay particles, which can block the spaces between the ore and hinder the even distribution of cyanide solution. It consists of conveyor belts, bearing, motor to drive belts, motor to lift the cement, cyanide water delivery pipes inside rotary drum. Slide number 4. Key steps in the agglomeration process: initial preparation. The ore is crushed to the required size, typically ranging from 9 to 12.5 mm. The purpose of this crushing is to increase the surface area available for the cyanide to react with the gold in the ore. This ore could be coming from the mine or coming from artisanal mining tailing. Slide number 5. Water addition. A certain amount of water, usually around 8% to 12%, is added to moisten the ore. Water helps in creating small wet particles that facilitate adhesion and cohesion of the agglomerates. Slide number 6. Binder addition. A binding agent such as cement or lime is added to a proportion of typically 1% to 3% of the ore weight. Cement is preferred due to its high ability to stabilize the agglomerates and improve cohesion between the fine particles. By the way, when the pH is low, then we add more cement because the cement increases the pH. Also, cement prevents formation of HCN gases. It is a poison gas. Slide number 7. Cyanide, NaCn, sodium cyanide. The addition of cyanide in the agglomeration process during heap leaching aims to enhance gold recovery efficiency by desaturating the outer surface of the agglomerates with cyanide, as shown in the equation: Au plus 8 NaCn plus O2 plus 2H2O equal NaAuCN plus NaOH. This equation called cyanidation. Okay, very good. The ore is mixed with a low concentration cyanide solution ranging from 0.5 to 1 kilogram of sodium cyanide. per ton of ore during the agglomeration stage, which improves chemical interaction and speeds up the extraction process in the final stage. This step helps reduce the leaching cycle time and increases production efficiency. We calculate the concentration of cyanide in the agglomeration pond through a laboratory process known as titration process. This involves titrating a sample of the cyanide solution with silver nitrate called ammonia using a potassium iodide as an indicator. We calculate the cyanide concentration at the moment the solution changes color to yellow during the titration process as shown in the equation here. NaCn plus AgNO3 equal AgCN to Na plus NaNO3. Ki, so potassium iodide plus AgNO3 silver nitrate equal Agi yellow PBT. Very good. I will explain the process in detail in a dedicated video covering all the laboratory procedures related to gold analysis. This includes analysis using the atomic absorption device, and also we have solid sample analysis, aquaregia process, pH device, titration process, and standard preparation. Also, we will discuss sample dilution. Slide number 8, agglomeration and screening and quality control. In this stage, the moistened ore is mixed with the binder in rotating drums known as rotary drums. During this process, the ore particles start to clump together, forming small balls known as agglomerates. Screen and quality control. After agglomeration, the agglomerates are screened to ensure uniform size and quality. High quality agglomerates should be strong enough to withstand the leaching process without disintegrated or breaking apart. Slide number 9. Placement of heap. After forming the agglomerates, they are evenly distributed on the leach heaps. The heaps are then sprayed with cyanide solution to extract gold from the agglomerate ore. We will explain this in detail in the next video. Slide number 10. Importance of agglomeration. Improve permeability. Agglomeration improves the distribution of the leaching solution within the heaps and prevent clogging. Number 2, increase leaching efficiency. The agglomerated ore provides a better service for cyanide reaction, enhancing the gold recovery rate. Number 3, reduced chemical usage. Due to improved interaction between the ore and cyanide solution, the use of chemicals like cyanide is significantly reduced. Number 4, reduced clay adhesion. Agglomeration minimizes the impact of clay present in the ore, which can cause issues in solution flow. With this, we have completed the first stage of gold processing using the heap method. In the next video, we will move into the second stage, which is preparing the heap and explaining its whole process step by step. If you found the video helpful, please subscribe to the channel and leave your comment. Stay safe and goodbye.